Hi everyone, welcome to my lecture, that is Cauchy's integral formula. This is in complex analysis. The topic is Cauchy's integral formula. Cauchy's integral formula. This is the first lecture. The learner will be able to understand in this lecture, that is statement of Cauchy's integral formula. This is the statement of Cauchy's integral formula. And using this formula, I will do one sum and some examples where it is applicable. Cauchy's integral formula, where it is applicable, I will discuss in this lecture. Okay, so let's see. Statement: if fz is a analytic function, fz is an analytic function. What is analytic function? That means the function which satisfies CR equation. CR equation. You know this. What is analytic function? Within and on a closed curve C. On a closed curve C. Closed curve means that is starting and ending point are same. That is closed curve means it may be a circle, it may be a rectangle, it may be a square. This is a closed curve. Closed means all are closed like this. This is a closed curve. See, closed curve. See, it may be square. It may be square. This is closed curve. Okay, starting and ending. Here start from here, then comes here, then ending is here. Starting and ending point are same, then it is a closed curve. So fz is analytic function within and on a closed curve C, and z equal to z0 is any point within C. Then fz0 equal to 1 by 2 pi I integration fz by z minus z0 dz. So this is actually Cauchy's integral theorem. Cauchy's integral formula. Cauchy's integral formula. Be careful. First lecture. Okay. And here you see z equal to z0. Z equal to z0 means here z0 is a singular point. Z0 is a singular point. Z0 is a singular point. Okay. So now this formula again can be written as, that is this equal to this into this, that is integral C fz into z minus z0 dz equal to 2 pi I into f of z0. F of z0. What is z0? Z0 is a singular point. Z0 is a singular point. Like if a function is always analytic, no singular point, then integration of this part is equal to, directly you can write 0. Like suppose fz, fz equal to, suppose that is polynomial function, polynomial in z. Like suppose fz equal to, suppose z square plus 5. So this is a polynomial function. fz equal to say sin z, or fz equal to say e to the power z or e to the power minus z. These are all polynomial function. This is polynomial function. So every polynomial function is analytic function. If fz equal to z, this, that is, then integration over any curve, that is integration of any curve, that is fz dz, is directly you have to write 0. Directly you have to write. If it is a polynomial function, fz is a polynomial, analytic function. If fz is an analytic function, then integration along any curve. Any curve, I mean, it may be a circle, it may be a square, it may be a rectangle. We won't see which curve it is. It may be a circle, maybe that is any closed curve. That is it may be a square. Okay, so integration of this equal to, directly you can write 0. So Cauchy's integral formula is applicable when there is a singular point. There is not only a, there may be there must be singular point, maybe 2 singular point, maybe 3 singular point, and we have to see whether the singular point is inside the closed curve. Here z0 is suppose inside the closed curve. Here z0 is suppose closed curve is a circle, then we have to see the singular point is inside the closed curve. If it is inside the closed curve, then we have to use this formula. If it is, if the singular point lies on the closed curve, then we have to use this formula for getting the integration value. Okay, suppose the singular point is outside the, this z0 is outside the closed curve, then we can write integration of dz, that is this part integration will be directly 0, that is integration of fz by z minus z0 dz is equal to, that is 0. If z0 is a singular point, but it outside the integral, then directly this value will be 0. If it is z0 lies inside the circle or inside the closed curve, not only circle, it may be square, it may be rectangle, or it may be any closed curve. Okay, if it inside the closed curve, then we have to apply Cauchy's integral formula. Cauchy's integral formula. Okay, if there is no, suppose there is no singular point, what I am saying, just try to understand. If there is no singular point, suppose fz equal to this, z square plus 5, it is always analytic function. Fz equal to sin z, it is always analytic function. Fz equal to e to the power z, it is always analytic function. Fz equal to e to the minus z, fz equal to cos z, always, these are all always analytic function. So integration of this function, that is analytic function, over any curve, we won't see which type of curve, which type of closed curve, any closed curve, this integration directly you have to write here. We will see, you will see after some video, I'll explain that thing also. So today we are discussing about only Cauchy's integral formula. That means there must be Cauchy's integral formula is applicable then when there must be singular point. There must be a singular point, not only on singular point. It may be 2 singular, maybe 3 singular. One by one, step by step, I will do the sum. Okay. So now let's see an example. Let's see an example of this application of this, that is application of Cauchy's integral formula. Application of Cauchy's integral formula. Very important. This is important for BC, BSc, B.Tech, IIT, JAM, CSIR, NET, GATE exam. Okay. So very important sum. I am taking a sum. From that is from question paper, university question paper. Before that, I'll explain. Suppose the curve, like suppose z minus z0 is equal to r. So this is equal to r. This means, what do you mean by this? This means that this is a circle. This is a circle. This is a circle whose center is 0, 0. Whose center is 0, 0. Sorry, z mod z. This means that this is equal to r. This means it represents a circle center 0, 0, radius is r. Suppose mod z equal to 2. What do you mean by this? Mod z equal to 2. That means it will represent a circle and radius is r. How? That is z equal to, if I write x plus iy, then mod equal to 2. So x square, modulus of this formula, x square plus y square root over is equal to 2. So x square plus y square equal to 2. So this will represent, that is 2 square. So that is, this means this is a circle whose center is 0, because x minus 0 whole square plus y minus 0 whole square is equal to 2 square. That is x minus 0 whole square. That is, this and these are the center and 2 is the radius. Okay. So what we have learned from here, if mod z equal to r, so the curve, that is closed curve like this, then we can say directly center 0, 0, radius is r. Radius is r. Now suppose mod z equal to say mod z minus z0 is equal to r. So it will also represent a circle whose center is z0, radius is r. Suppose z minus a equal to r. So this is again a circle whose center is a0, and radius is r. Radius is r. Z minus a, like suppose z minus 2 is equal to 3. So center is 2 comma 0, radius is 3. How? You have to put z equal to x plus iy, then it will be x minus 2 whole square plus y square is equal to 3 square. So that means center is 2 0 here, center is 2 0, radius is 3. So now suppose z minus bi. So z minus bi equal to r. Then so suppose the closed curve is like in this form, z minus bi. Like so this means this says that center is 0 comma b, radius is r. Center is 0 comma. Like for example, suppose z minus 3i. Z minus 3i equal to 5. So what do you mean by this? That is center is 0 comma 3. Radius is 5. Suppose the closed curve, like suppose z minus a plus ib. Equal to r. So what do you mean by this? This means that center is a comma b, radius is r. So this will require when we have to solve the problem of Cauchy's integral formula. Using Cauchy's integral formula, this will be required. That means sometimes the closed curve like in this form, then directly we can find the center and radius. This will be required. Okay. I think everybody understood this part. Okay. Now I am going for how to solve a problem using that is Cauchy's integral formula. Okay. Let's see. I am taking a sum from university question paper, and I will take some from CSI or NET exam or GATE exam previous year question paper sum. Sometimes I will solve. This is the first lecture, and the second lecture I will do sums on that is Cauchy's integral formula. In this lecture, only one sums I am doing here. Like suppose the question is, this question came so many times in the question paper in the university exam, that is evaluate integral e to the power z by z minus 2 dz, where c becomes, that is mod z is equal to 3. This sum, very important sum. This sum, evaluate e to the power z by z minus 2. So now you see, this is a function, that is, if we take this as fz, then fz is not defined when z equal to 2. That is, to get the singular point, we have to put the denominator part is equal to 0. Then the value of z is known as singular point. To get the singular point, this is the rule. To get the singular point, we have to put the denominator part equal to 0. Denominator part equal to 0. Okay. Denominator part is equal to 0. Okay. So z equal to, if we put z minus 2 equal to 0, then z equal to 2. Z equal to 2 is a singular point. Singular z equal to 2 is a single. 2 can be written as 2 plus 2 plus 0 into I, that is 2 comma 0. As you know, a plus ib equal to, a comma b. Like a plus ib is equal to a comma b. So this can be written as 2 plus 0 into I, that is 2 comma 0 is a singular point. This is a singular point. Now we have to see whether this singular point lies inside the curve or on the curve or outside the curve. This is very important. This is very important. We have to see whether the singular point is lies on the curve. That is what is the closed curve here? What is the closed curve? The curve is that is mod z. Mod z is equal to 3. So this means this is a circle. As already I have discussed, this is a circle of radius 3. So circle center is 0, 0. Center, this is a circle, center 0, 0. Radius is equal to 3. 3 radius equal to 3. So circle, this represent a circle center 0, 0, radius 3. Now if we draw a circle like this, this is the circle, center is 0, 0, 0, 0. Now if we, this is 0, 0. Okay, this is 0, 0. And what is the radius? This point is 3, 0, because 3 is the radius. This is x-axis, this is y-axis, and this is O. Center is 0, 0. Now you see whether the singular point inside the circle. Yes, 2, 0. Singular point is, what is singular point? Singular point is 2, 0. 2, 0 lies like inside the circle. This point is 2, 0. This point is 2, 0. This is the closed curve. This is the closed curve C. This is the closed curve C. So center, that is singular point, lies inside the circle. So we can apply Cauchy's integral formula. Cauchy's integral formula we can apply because the singular point lies inside the circle. See, 2, 0. Yes, 2, 0 on the x-axis, it will lie on the circle, inside the circle. Okay, if 2, 0 suppose outside the circle, suppose you are getting 3, 0 or 5, 0, suppose that is a singular point is 5, 0, so it is outside the circle, so then directly this value will be 0. I will tell you. Okay, now you have to write this part, since singular point lies inside the closed curve C, that is circle, inside the circle. Okay, inside the circle. Therefore using this formula, what is z0 value? Z0 is equal to 2 here. Z equal to 2 means, therefore Z0 equal to 2 is a singular point. That is, this point is lies inside the circle. So therefore integration C over fz. What is fz here? Fz we have to take e to the power z. Fz by z minus z0. Z minus z0 dz is equal to 2 pi I into fz0. What is z0? Fz. Fz is equal to, you take, that is e to the power z. Generally, we take that fz, that is function of z, you take in the numerator part. Okay, numerator part. So this is the rule. Okay, so now 2 pi I into f0 means z0 means z equal z0 value is 2. That is 2 is the only singular point. It is inside the circle. So now what is f2? That is e to the power 2. If we put f z equal to 2, then e to the power 2. So that is 2 pi I into e to the power 2. So this is the answer, e to the power 2. So this is the answer of this sum. That is integration, we can say integration C. What is fz? E to the power z by z minus, what is z0 value? Z0 value is 2 dz. So this value is, this is the answer. Okay, so I think everybody understood very nicely. So now the question is, suppose e to the power z by z minus 5 here, e to the power z by z minus 5, that is z equal to 5 is a singular point. So it is 3, 0, that means 5, 0 is a singular point. It is outside the circle. outside the closed curve. So directly you can say integration e to the power z by z minus 5 dz is equal to 0. Directly you can write that is 0. Okay. I think everybody understood very nicely. So keep watching, sharing, and commenting this lecture with your friends. Don't forget to hit the subscribe button and notification bell. I'll come with my new lecture, that is lecture number 2 in Cauchy's integral formula. Till then, bye bye. Thank you.